So how to improve your real-time testing, especially of algorithms. I'm here with a domain expert and we're here at MATLAB Expo at Silverstone. Very exciting to be here. And I'm here with Joscha Kunz. You are the Chief Customer Officer at Speedgoat and you focus all the time on real-time testing. And especially if we look into the domain where we have, for example, model-based design with simulations and where you have integrated with tools, real-time testing tools, for example, for on one hand the prototyping, but also the hardware in the loop. Can you explain more?
Yeah, sure. Thanks for the introduction. Yeah, I mean, at Speedgoat we basically have a platform where it lets you deploy your control algorithms, your control strategies onto a generic platform, which is already physically connected as your real controller to your system. So you can verify very early on during the development and make sure that your algorithm is actually performing as you want, directly in real time and tunable during development.
And does this make it more transparent because you know how it responds and therefore it makes it more transparent?
Yes, the transparency is actually a key, and to have a transparency from requirements to the testing. And one first step is to verify that your controller is actually complying with the requirements, which you actually can directly link and verify within Simulink.
And are there other requirements that are next to the transparency which are really, yes, spot on and important?
Yeah, I mean, you want to make sure that all the functionality is actually covered, and you want to make sure it's safe and reliable, so that you are as well confident that your system is not harming people, depending on what it is.
Yeah. And on the other hand, we see now AI coming into the whole process. How do you support the engineers in supporting this new type of technology as well?
That's a very, very good question, because indeed it's reshaping how engineers develop their controller, design their controller, but as well how they test it. So there are different, let's say, stages or phases where it has impact, and I think one is during development. So it seems like the engineers nowadays, it shifts a little bit away from hand coding, from manual modeling, etc., towards more intent-driven development, if you will. So you focus more on the why and the what, and let then AI help you with the how, and generates then the code or the models, etc., automatically.
So yeah, basically the role of the engineers is changing.
It's changing indeed, yeah.
Yeah, and we were talking about as well all the type of challenges, especially you have your models. Models and simulations are always a representation of the reality, and how to get as close to reality. So can you explain this process? And it's never ending, of course, because real is always a little bit different than...
Absolutely true. I mean, there is no model which is the perfect mirror to reality. That doesn't exist.
Yeah.
It's a matter of what is close enough. And there is something I would always call the art of hardware in the loop is to define the minimal fidelity needed to have enough realism to cover your test case, because it very much depends on what you test, which defines how much reality you need in the model. So on one hand you have, let's say, a component level testing, so you have a power electronics converter controller. So you want to maybe have a physical model representing even the switching behavior of an IGBT, because you want to test your controller that it behaves correctly. So you need a very high fidelity, high dynamic model. When you more go to system integration testing, then maybe an average model is totally fine, because you're more interested in testing the interaction between the different controllers in the system. So depending on what case you have, you should actually define the fidelity of your model to make the process at least complicated as possible.
And what are the key challenges basically that engineers are facing in this process?
Yeah, you first have to obviously build a model, and you have to, a good starting point there is to have kind of pre-built libraries, physical multi-domain libraries for mechanics, electrics, etc., so you can build a model around. But you want then to as well enhance this with your own mathematical equations, etc., and you want to maybe as well cross-check that with measurements you have taken in the real world. So you can then actually use curve fitting or model analysis tools to actually verify and tune the realistic behavior of your model against real world data you have measured before.
And last but not least, look a little bit more into the future. What is the direction what we can see at real-time testing, either from algorithms or from hardware in the loop, for example?
Yeah, I mean, there are several trends, of course. I think one of the trends which is interesting is that model-based design, as it has to be proven very efficient and the return on invest is quite high, is that further industries are actually adopting this. It's traditionally automotive and aerospace, as we know, but as well they are adopting it further. But it spreads as well to medical, energy, industrial automation, and so forth. And that's definitely a trend we see. But then there are as well other trends which are maybe less kind of technological. It's more like where and when you test. So it's on one hand physical, but the other thing is as well where in the development cycle. So people now want to connect basically development and testing and not have it purely separated, but connect this as early as possible to verify the algorithms, not at a very late stage, but as early as possible.
Yeah, speed up the quality and reduce the cycle time.
Absolutely, absolutely.
Joscha, thanks a lot. Great insight. And if you want to learn more, look at MATLAB Expo. There's much more information that can help you with real-time testing. Thank you.
Thank you.